we're going to talk about the derivative for the natural logarithmic function. And so just like when we did exponentials, we're only going to learn one basic rule, which is that the derivative of the natural log of x is equal to 1 over x. Now, we don't need to memorize all the other rules that are in the textbook. We just get to use the chain rule. Again, the chain rule, very useful. And once you practice enough, it will become second nature, hopefully. So let's try an example. Let's say we want to take the derivative of the natural log of 6x squared minus 3. Now, what would be the inside function to use the chain rule? Well, it would be the 6x squared minus 3. So to take my derivative here, I'm going to do the derivative of the outside, so derivative of natural log. So it's just going to be 1 over whatever's inside the box, which is 6x squared minus 3, times now the derivative of what's inside the box, which is going to be 12x. The derivative of 6x squared minus 3 is 12x. So this will give me 12x over 6x squared minus 3. Technically, I could probably divide all of those terms by 3, and I could get 4x over 2x squared minus 1. And there's my answer. Once again, I'm just using the chain rule. I'm not memorizing all of the new formulas. You can memorize the new formulas if you want to, but you certainly do not have to. And so this is derivative of the outside. And this was derivative of the inside. And let's try this next one. I kind of did some nested chain rules here. So let's take the natural log of x squared, but let's raise all of that to the 5th power. So when I start to do my chain rule, I say, well, what's the inside function? So the inside function is actually this natural log of x squared. So when I take my derivative, say, okay, so I have something raised to the 5th power, so that derivative will be 5 times whatever's inside the box raised to the 4th power. And inside my box, I still have the natural log of x squared. Times, now I need to do the derivative of what's inside the box. But notice inside the box, we have another chain rule. So now we have x squared is inside the box. So derivative of the outside, derivative of natural log is 1 over x, or in this case 1 over x squared, since that's what's inside the box, times the derivative of what's inside the box. Derivative of x squared is 2x. Okay, so this is the derivative of the outside. This is derivative of the inside. And this is derivative of the, let's call it inside. So we did a nested chain rule there. And my final answer, 5 times 2x, oh, let's just see, 5 times 2, this x and that x will cancel. So 5 times 2 is 10 over x times the natural log of x squared, all raised to the 4th power. So again, memorize your one simple rule that the derivative of the natural log of x is 1 over x, and then just use your chain rule for everything else. But now we're going to do a type of problem where we might want to simplify using laws of logarithms and then take the derivative. So for example, let's say we want to take the derivative of the natural log of x squared times 5x plus 3 all over 7x minus 6 raised to the 10th power. We don't want to do this. Not only would we have the chain rule and lots of chain rules nested in here, but we also have a product and a quotient rule. This would be a mess to take the derivative using our traditional techniques. But what we can do is we can simplify using the laws of the natural logarithm. So before I take that derivative, let's simplify. So if you remember, if we have a product inside a log, we can bring that out as an addition. So we can say that this is the natural log of x squared plus the natural log of 5x plus 3. And when you have a division, you just subtract. Subtract the natural log of 7x minus 6. Now what about this 7x minus 6 raised to the 10th power? That would be a fairly simple chain rule, and I could do it. Or I could bring out the 10 as a coefficient. Notice now I don't have a product rule, a quotient rule, I guess a multi-level step chain rule. I just need to take the derivative of this entire term, but everything is now so much simpler than it was before. So let's go through and take that derivative. So the derivative of the natural log of x squared, let's do that piece first. We're going to do 1 over x squared times 2x because I'm using the chain rule. So I had a box around the x squared. Okay, plus, now natural log of 5x plus 3. That's going to be 1 over the 5x plus 3 times the derivative of the inside. Derivative of 5x plus 3 is 5. Minus 10 times, now we'll take the derivative of the natural log. So derivative natural log of 7x minus 6 is going to be 1 over 7x minus 6 times the derivative of the inside, which is 7x minus 6. The derivative of that is 7. So for my final answer, let's see, that x cancels, so we have 2 over x plus 5 over 5x plus 3 minus 10 times 7, so 70 over 7x minus 6. And that's my final answer. Notice that was much simpler than trying to take the derivative of the inside of that original log function. So all those log properties we learned so long ago and we're making you practice again, they actually do have a use here.